Assalamualaikum and hi. We would like to present the solving Sudoku puzzle using graph coloring and Python. Our group consists of 3 members, which is the first presenter is me, Nur Anisha binti Zabidin. The second presenter is Ellyna Safia, and the third presenter is Zulaika. For the introduction, Sudoku is the problems that involve logic and combinations of number. It is played on a grid. There is 9 by 9 in size and is broken into 9 smaller subgrids, each measuring 3 by 3. The objective is to populate the grid so that every row, column, and 3 by 3 subgrid has all the numbers from 1 to 9 without duplication. Typical problem solving techniques involve searching for clear position, cross-hatching to analyze relationship between rows, column, and subgrid, and making preliminary notes or likely numbers, and applying logical deductions to eliminate alternative. One of the concepts of the graph theory applied is the graph representation. The Sudoku grid can be represented as a graph where each cell within the Sudoku grids can be denoted as a vertex. Furthermore, each connect vertices corresponding to cell within the same row, column, or 3 by 3 subgrid. Next is transform Sudoku into graph coloring, which treats Sudoku as a problem of assigning colors to the graph. Within this structure, every individual unit within the Sudoku grid is considered a vertex. A connection are established between vertices that are part of the same row, column, and subgrid. The color are assigned to digit 1 to 9, and the objective is to color the vertices so that no two adjacent vertices have the same color. This approach entails representing the puzzle as a graph, establishing connection between cells based on Sudoku rules, and subsequently employing graph coloring methods to assign number to cell while guaranteeing the absence of the conflicts. Methods such as constraint satisfaction and break tracking can be applied to discover the solution. As for the Python libraries, the first Python libraries that has been used is NetworkX. NetworkX is a library for creating, manipulating, and studying complex network of node and edge. Furthermore, NetworkX can represent the Sudoku grid as a graph in which each cell is node and there is connected to other nodes within the same row, column, and subgrid. Graph representation can be applied to implement algorithms such as backtracking or constraint satisfaction. It will use to create and manage Sudoku grid. As for the matplotlib, is to plotting the graph for the visualization of the graph and the result.
Next is problem modeling. A Sudoku grid can be represented in a graph with nodes and edges. Nodes represent the squares in the Sudoku grid, and edges represent the constraints between the nodes. For standard 9 times 9 Sudoku, each node contains a number from 1 to 9, and empty squares are usually filled with 0. The constraints that exist in Sudoku include row constraints, column constraints, and box constraints. Row constraints mean that each number 1 to 9 must appear exactly once in a row. Column constraints allow each number 1 to 9 to occur exactly once in a column, and box constraints permit each number 1 to 9 to appear only once in a 3 times 3 subgrid or box. Let me show you how to construct a 9 times 9 Sudoku grid with Python. First, import networks and matplotlib.pilot. Then define the Sudoku graph. Next, add nodes for each cell and edges for row and column. Then add edges for box constraints and plot the graph that represent a Sudoku grid. This is a simple graph representation of Sudoku grid by Python. Now that we understand how to construct a Sudoku grid with graph in Python, we can finally construct the graph to represent an unsolved Sudoku puzzle with graph coloring concept. The first step is the same. Import necessary libraries, define Sudoku graph, add nodes, edges, row constraints, column constraints, and box constraints. Then we color the nodes that contain a number. Nodes that have the same number will have the same color. Then we plot the unsolved Sudoku puzzle. This is the colored graph representation of unsolved 9 times 9 Sudoku puzzle.
Assalamualaikum warahmatullahi madam. My name is Kimsani. I am going to present to you for the graph coloring algorithm. So for the first coding, I will show the backtracking algorithm without the graph coloring. So backtracking is a general algorithm for finding all or some solution to computational problem and a suitable constraint satisfaction problem. This increment will candidate to the solution and abandon a candidate as soon as it determines that the candidate cannot lead to the valid solution. For Sudoku, this means trying number in empty cell and backtracking if a number leads to an invalid state. So first, for the first is we have a function print grid to print the Sudoku grid. This helps us to visualize the grid to any point during execution. So this is the coding. This function simply iterate over the 9 times 9 grid and print each element. Next is we need a function to find an empty location in the grid. This helps us to identify where to place the next number. This is coding. To find the empty location function, search the grid for an unsigned location and denote it by 0. If it finds 1, it's updated to provide list 1 with the row and column to indices and return true. If no assigned location is found, it's returned false. Okay, next is to ensure a valid Sudoku solution, we need to check if the placing a number in a specific cell is allowed according to Sudoku's proof. So this is the coding. So we have 3 helper function, which is used in row, used in column, and used in spot. This function check whether a given number already exists in the specific row, column, or 3 by 3 subgrid respectively. Okay, next is combining the previous check. We can now create the function to verify if placing a number at a particular location is safe. So this is the coding. The check location is safe function return true if the number does not violate any Sudoku constraint in the row, column, and 3 by 3 box. So now we look at the code of our program. The solve Sudoku function that use backtracking to solve the puzzle. And this is the coding. Okay, for the next is the solve Sudoku function. Try to fill the grid recursively. If the first find an empty location, if no empty location is found, the puzzle is solved. For each empty cell, is try number from 1 to 9. If the number is valid, it assign it and recursively try to solve the rest of the grid. If placing the number leads to an dead end, you reset the cells and try the next number. This backtracking continue until a solution is found for all possible or exhausted. So for the coding, this is the Sudoku that we want to solve. In the main function, we define a 9 times 9 grid with the prefill value and call solve Sudoku to solve it. A solution found, it print and solve the grids. Otherwise, it prints no solution exists. So using practical algorithm, our program sets will solve the Sudoku puzzle. This is approach simply explore all possible and backtracking when it encounter conflicts, ensure a valid solution. This project demonstrates the power and simplicity of backtracking in solve constraint situation problem like Sudoku. So this is a video of our coding for the backtracking without the graph coloring algorithm. So this is how the coding run, and successfully run the coding. This is a video. Okay, next is the coding with the graph coloring and the backtracking algorithm, combining the goods algorithm. To model Sudoku as a graph, represent each cell in 99 grid as a node. Edges exist between nodes and in the same column and row, bound by 3 by 3 subgrids. So firstly, we import the necessary library network X to for creating emulating graph and upload lib for visualization. This is function. So next is define the create Sudoku graph function. This function is take a 99 times 9 Sudoku grid as input and create a corresponding graph where each node represents a cells in the Sudoku grids. Each are added between nodes that must contain different values. This is the coding. Next is adding nodes. Okay, the first loop iterates through each cell in the 9 times size Sudoku grid. Each cell is added as a node to the graph G. This node represented by a tuple, row, column, and store the value of the corresponding Sudoku cell as an attribute. Adding edges for rows. This loop add edges between all pairs of nodes in the same row. For each row, it iterates through each pair of column and add edges between row and column 1 and row and column 2. For the next slide is editing edges for collapse. So this is the coding. This loop at edges between all pair of nodes in the same column. For each column, it iterate through each pair of row, and add edges between row and row. For example, row 1 and column, and row 2 and column. So editing edges for 3x3 subgrids. This part at edges between all pair of nodes in each 3x3 subgrid. It iterate each subgrid particularly by block row and block column. Within each subgrid, it add edges for pair of nodes in the same row and in different row. Next is the function return D is the function return the created graph. Okay, next slide. We will define the isValid function. This function is a given color to be assigned to a node without violating the Sudoku rules. So next is define the graph coloring function. The function attempting to color the graph using backtracking approach. This is the coding. So parameter G, a graph representing the Sudoku puzzle, colors a list of available color from example number 1 through 9 for a Sudoku puzzle. Coloring is a dictionary represent the current coloring of the graph. The node list is a list of nodes to color. Index is the current index in node list. Okay, next is define the solve Sudoku function. This function attempts to solve the Sudoku puzzle with graph coloring. The function takes some pattern Sudoku grids as input. This creates the graph representation of solved Sudoku by calling the get solved Sudoku graph. It defines the possible color number 1 to 9 that can be used for coloring the graph. It initializes an empty dictionary coloring to store the coloring nodes. Next, it prefers the graph initial Sudoku value. Function initially iterate for each Sudoku grids. Next is the create list of nodes to color. This is the function. Attempt the color graph. This is the function for the attempt to color graph. Okay, next is define the draw Sudoku graph function. This function visualizes the Sudoku graph using the network and matplotlib. This is the coding. So next is we print the Sudoku function. This function prints the Sudoku grid in a human readable format. Okay, next is we start defining the Sudoku puzzle where 0 represents the empty cells. This is Sudoku puzzle that we want to solve. We use the print Sudoku function to display the Sudoku puzzle. So we call this solve Sudoku function to attempt to solve the puzzle. If the function returns true, the puzzle will successfully solve. Otherwise, no solution exists. So coding for that. Okay, next this is video where we try to run the coding. So as you can see, the coding is run successfully. Okay, next this is video where we try to run the coding. So as you can see, the coding is run successfully. Okay, next this is video where we try to run the coding. So as you can see, the coding is run successfully. Okay, next this is video where we try to run the coding. So as you can see, the coding is run successfully. Okay, next this is video where we try to run the coding. So as you can see, the coding is okay. Here we see the engineering Sudoku grids and solve the Sudoku grids. By applying the graph coloring and backtracking approach, we can effectively solve this puzzle. This method not only address to all Sudoku constraints, but also demonstrate the power of graph theory in solving complex problems. So in conclusion, we have successfully applied graph coloring and backtracking algorithm to solve Sudoku puzzle. This approach highlight the practical application and the graph theory and algorithm design. By treating Sudoku as a graph coloring problem, we can leverage powerful technique to find solution effectively. The method can be extended to other constraints, situation problem, and showcasing the versatile of a graph theory. So this is the solution that we get from the coding. So as we see, the coding is the solution is we get successfully. That's all for me. Thank you, madam.